As we continue examining the three forms of a linear equation, your slope-intercept, your point slope, and your standard form, linear equation in standard form is useful for making quick graphs. It's an efficient way of varying an equation in its form to create the table of values by substituting 0 for x and find the corresponding y value, then substituting 0 for y and find the corresponding x value, and what you give are those are your intercepts, which would be easy to graph. And we'll go through and we'll practice some of this, but each form has its own benefit, and in this case we're able to quickly find our intercepts and graph those 2 points to create a line. So as we look here, the standard form of a linear equation is going to be something along the lines of that. Ax plus by equals c, and a, b, and c are real numbers, and a and b are not 0. So as we look here at finding x and y intercepts, we need to take into account that when I'm talking about an intercept, that is going to be where a line crosses over my axis, this being the x-axis, this being the y-axis. And we know that this point right here, when we have 0, 0 of my origin, the x value is going to be 0 and the y value is just going to be some number. And then on the x-axis, the y value is going to be 0 because that's the value on the axis, and then there's going to be some x value. So looking at my intercepts and thinking along the zeros and what that means, as we are calculating the x-intercepts, what we're going to do is we're going to substitute in those 0 values and find out what the others is. So what are the x and y intercepts of the graph of each equation? Well, if I want to find the y-intercept, x is going to be equal to 0. So we just take and we substitute in 4x 0, and then that will provide us the information we need to determine the y-intercept. So of course 5 times 0 is 0, so we have negative 6y is equal to 60, and I'm going to divide both sides to isolate my y, and then I have y is equal to negative 10. So in this case my y-intercept is going to be 0, negative 10. That is going to be where my y-intercept occurs. And if I look over at now to find my x-intercept, well, my x-intercept is when y is going to be equal to 0, so I would have 5x minus 6 times 0 equals 60. And then of course I have 5x then is equal to 60, or once I divide my coefficient away, I have x is going to be equal to 12, or my x-intercept is going to be 12, 0. So I have my y-intercept, and I have calculated my x-intercept. And doing the same here for the next one, if I go to, on B here, I have 3x plus 8y equals 12. Going for my y-intercept, we know that x is going to be equal to 0. So I have 3 times 0 plus 8y equals 12, and that is 8y equals 12. Divide both sides to isolate my y, and y ends up equaling 3 halves. So my y-intercept then is going to be 0, 3 halves. And if I go to calculate my x-intercept, and I know that y is going to equal 0, so I have 3x plus 8 times 0 equals 12. 3x equals 12. Divide both sides by the coefficient, and then x is going to be equal to 4 on my x-intercept, so that would be coordinate 4, 0. There's calculating my intercepts quickly using the standard form. That's one of the largest benefits of the standard form. Most often not used, but it does have its value. So now if we graph a line using these intercepts, well, if I go back to calculating my my y-intercept, again, is when x is equal to 0. So I'm sitting with, that would be 2 times 0 plus 5y equals 20. And then that becomes 5y equals 20. So you divide both sides by 5 to isolate your y. And y then is 4. So I know then that my y-intercept is going to be 0, 4. Then calculate my x-intercept. Again, the x-intercept, y is going to be equal to 0. So I have 2x plus 5 times 0 equals 20. And then I have 2x equals 20, dividing both sides by the coefficient. And x is going to be equal to 10. So my x-intercept has become 10, 0. So if I go to graph those on my coordinate plane, so creating my coordinate plane, so I have y-axis, x-axis, and I'm going to go ahead and do my intervals by 2, just to make it, just to make it a little bit easier to graph 10 on a coordinate line, so I don't have to make a whole bunch of different lines, or a whole bunch of different points. So I have 2, 4, 6, 8, 10, 12, and we determined that my y-intercept was 0, 4, so 0, 4, and my x-intercept was 10, 0, and there you go. We have a line now. We have 2 points where we can connect them, and we've graphed a line using the standard form of an equation. And if you needed to later on, you could determine your slope. Not that it's asked us to right now, but we know that my slope is going to be my rise, which happens to be in this case negative 4 over my run, which is going to be positive 10. So I know that my slope m is equal to negative 4 over 10, or negative 2/5. So there you go. Let's see here. Let's go ahead and calculate. Here is when we are graphing, you want to make sure that, as we did here in this example, you go ahead and find and plot the x and y intercepts. That's what we've done, and then we draw a line through those 2 points. We were able to do it here. We calculated our intercepts and then drew a line. Now we are going to do some graphing on horizontal and vertical lines again. And so let's see here. Let's go ahead and create our coordinate planes. Okay, so when I go to graph horizontal lines, and if I wanted to, I could possibly rewrite this equation as, if I rewrote a here in standard form, I have 1x plus 0y equals 4. And I'm showing you this because I have 0y, so it doesn't matter, because the coefficient is 0 here, it doesn't matter what value I substitute in for y. Anything times 0 is going to give me a 0. So the input, or the value of y, will always, is not relevant. It doesn't change anything in this equation. So when I graph this, x is always going to be equal to 4. So as I graph that, I know that if I were to substitute y in for, or 1 in for y, well, x would still be equal to 4. If I substituted 2 in for y, x would be 4. 3, it would be continuing on that x is always going to determine to be equal to 4. Now, if I connect those with a line, there is my x equals 4, and it is a vertical line. Doing the same thing with b, x is negative 1. Well, x is always negative 1. It doesn't matter what I substitute in for y, right? X is going to be equal to negative 1. If I look at that equation and I substitute in a 3 for y, well, it's going to be x is negative 1. If I substitute in negative 3, well, x is still going to be equal to negative 1. So we've graphed two vertical lines. Now, and I guess I should be a little bit, x equals -1, x equals 4. Anytime you're graphing more than one line on a coordinate plane, you should always label them to where there's no misunderstanding what you're talking about and what you're showing. So if we do the same here with my y equals, and these are going to be horizontal lines, but that would be 0x plus y equals -3. So any value that I plug in for x times 0 is going to give me a 0. So that's why no matter what I do, y is going to be equal to -3. So as I plug in y is -3, that's down here, no matter what value of x I plug into my equation, I end up getting y is -3. And as I connect those points, I get a horizontal line of y equals -3. And correspondingly, as we go to y equals 1, well, y is going to be 1. The value of y right there is 1. And that is how you would graph another horizontal line. So moving on here, let's see, there's my transforming to standard form. Okay, so they have given us what you might see is what is y minus 2 equals -1/3 x plus 6, written in standard form using integers, okay? Using integers. So we're going to make sure that our a, b, and c when we're done are integers. And I have been given point slope form, and I want to convert that. So converting that, let's just go ahead and do some distribution, combining like terms, and we're going to move our x and y over to the left side and make it equal to the constant. I just said a lot, but I think in the end it won't be too difficult. So if I rewrite this after the distributive property, I have -1/3 x plus -1/3 times 6. And I get y minus 2 is equal to -1/3 x minus 2. Go ahead and combine like terms. I'm going to add 2 to both sides, and I'm going to have y is equal to -1/3 x plus 0, or if it's 0, we don't have to do anything with that. Or I guess I should leave it there, huh? Plus 0. Get in standard form, right? I got to have my x and my y on both sides, so I'm going to go ahead and add my 1/3 x to both sides so I can get them to the left, and I'm going to have 1/3 x plus y is equal to 0. Well, it does ask me to have an integer, and I should hopefully know right now that 1/3 is not an integer. And what can I do to make 1/3 an integer? Well, I can multiply it times 3. Okay, but if I multiply it times 3, I have to multiply everything times 3. So I end up getting here, that would be 3 times 1/3 x plus 3 times y equals 0. 3 times 0 is 0. We have 3y plus x. And there we go. We have my standard form of an equation. X plus 3y equals 0. Okay, so as we move on here, using standard form as a model, using standard form as a model, it says a media download store sells songs for $1 each and movies for $15 each. And we have $60 to spend. And it says write and graph an equation that describes the items that you can purchase. Let's see here. So we have we're buying two things. We're buying movies and we're buying songs. So if we'll make my songs equal to x. We'll make our movies equal to y. And then I know that I'm going to have the cost. The cost is going to be equal to the songs, the cost of the songs plus the cost of the movies. And I know that the cost is going to be equal to, the song is, we just said was going to be X plus the movies. And then how much are each one of those movies going to cost? Well, the song costs $1 and the movies are going to cost $15. So if I wrote that, that would be C cost equals 1x plus 15y, or C equals x plus 15y. And I can't forget that we said the cost is going to equal, we have $60, and why leave any money in our pocket, right? The cost is equal to $60, so I can go ahead and replace that with 60. And there's my equation. 60 equals x plus 15y. And if I wanted to find out my coordinate points, if I want to graph the y-intercepts, well, if I purchased 0 songs, how many movies could I buy? And if I purchased 0 movies, how many songs could I buy? So if I go ahead and replace, do some inputting here to do some calculations. Okay, so when I purchase 0 movies, I'm going to figure out how many songs I can purchase. So that means my X is equal to 60, so that would be 60 songs. If I purchase 0 songs, how many movies then can I purchase? And then that would be 15y equals 60 divided by 15. That tells me that I can purchase 4 movies if I purchase no songs. So this would be an ordered pair of 0 songs and 4 movies. My songs would be an ordered pair of 0 songs and no movies. So now I can go ahead and graph this. I've got 2 points. Okay, so I've gone ahead and created my coordinate plane. Of course, my input, my x value were my songs. In this case, just my x value, not necessarily my input. And then my y value were my movies. And if I go ahead and graph these points, so at 60, 0, if I have 60 songs and 0 movies, or also 4 movies and 0 songs, and now I can look at my cost basis is always going to be 60, right? But I can just go ahead and graph these 2 points. And then we should be able to see too that at, that would make sense that my line, my cost basis crosses over at 30. And if we were to check this point, this is 30 and 2. If I look at my equation and I say that my cost is going to be $60, and I use those values of 1 times x plus 15 times y, and I do substitution there, I get 30 plus 15 times 2, so I get 30 plus 30. Sure enough, that actual point checks out that I have 60 equals 60. So there are different combinations here that I can graph and see. So that's graphing, and of course, these of course were my intercepts. That's why I was able to graph them, looking at some values along the way. So I guess the only thing that, and we were also able to do it here where we calculated our 2 intercepts and graph them, and we're able to connect 2 points with a line, and there you go. That is using the standard form of an equation.